So we took 3. So it was 0, and we took 4. It was 15. So Rajiv, can you understand?
Can you explain again, brother, if you don't mind?
So we just take any value in between these two things, like minus infinity to minus 1. So you can take -2, -3, or -100, anything. So I just took -2. So it made 15. And then for -1, I took -1 here. Or I just substitute -1 here. So it will make 3 plus 6 minus 9. That means 9 minus 9, or 0. So f derivative -1 equals 0. Then here we have -1. We have -1, comma 3. So if you take any number, like I just took 2. So if this is 2, then 3 into 2 square, that means 3 into 4. Minus 6 into 2, that means minus 12. Minus 9. So this is 12 minus 12 minus 9. 12 minus 12 minus 9. So this 12 and 12 get cancelled, and we get -9. আসসালামু আলাইকুম ফারিন। হ্যাঁ, ওয়ালাইকুম আসসালাম। তুমি চলে আসো। হ্যাঁ, আমরা জুমুতে আছি। মিটিং আইডি দেয়া আছে এই যে আমাদের ইন্টারন্যাশনাল গ্রুপে। স্যার তোমাকে আবার দিচ্ছি এক সেকেন্ড। আমি ঘুমাই গেছিলাম ভাই ক্লাসের পরে। ওকে, আসো, এখানে সমস্যা নেই। আচ্ছা। তো এখানে এরপরে 3 বসালাম। হ্যাঁ, ও সরি। So now we substitute 3. So okay, I was talking in Bangla. Then we substitute 3 here. So it will make 3 multiply 3, that means 9. 9 multiply 3, that means 27. 27 minus 18 minus 9. So guys, you can calculate this. This is very simple. I don't need to waste time here. So this will make again 0. And derivative of 4, f derivative 4 is 15. Okay. Ajib, Topu, can you find?
Okay. Sorry.
Yes, I can.
Over, I have questioned that how can I get f derivative 4?
8 derivative 4. Okay. Where is 8 derivative 4? Okay, f derivative 4. Okay, I got it. So you have to take any value between 3 and plus infinity. For example, you can take 4, you can take 5, anything. We just need the direction, like if it is it upward or downward. Okay.
And previous one we have 3. Previous one we have 3. So how can I get 3?
Because there are 3.
You see here,
just only 3 there are.
This is open interval, so we cannot take this value 3. Okay, and here we have only 3.
Got it.
So here we have
got it.
Yeah. So you can see this is plus, this is a positive number, and this is a negative number, and this is a positive number. So sign of the f derivative will be here plus, here minus, and here plus. So this is increasing then, right? This interval is this is increasing.
Yeah.
And in this interval it is also increasing. That means from minus infinity to -1, and from 3 to plus infinity, our function is increasing. And from -1 to 3, our function is decreasing. So you can look at the graph here. See here, from minus infinity.
More explain the last one, please.
Okay, the last one. So if this is a positive number,
The last number.
if f derivative is positive number, so our function will increase, okay? And if
Increasing.
if f derivative
Oh,
is
okay,
negative number,
okay, I got
it will decrease. So
you.
you
Can
see
move
here,
on. You can move on.
yeah. From minus infinity to minus 1, it is increasing. So if you look at the graph, this is our minus infinity, and this is our minus 1. So this in this portion, this function is increasing. And from minus infinity, from minus 1 to 3, this function is decreasing, right? You see here, this function is decreasing.
Yes.
And then again from 3 to minus plus infinity, this function is again increasing. And we have two local extreme value. One is local maximum and another one is local minimum. So local maximum look like this way, like a hill, okay? And local minimum, this looks like a lake, or like a lake, okay? Bottom point of a lake. And local maximum looks like a top point of a hill. So this is our local maximum and this is our local minimum. So guys, do you understand?
Yeah.
Okay, Zakira, can you understand?
Yeah.
Rajiv, Farin? Farin is late, so Farin will not understand, I think.
Faridul.
Exactly.
Faridul is not in the meeting.
Faridul was here, but
Yeah,
maybe.
Faridul was here. Faridul is brilliant, I know, okay, so.
Yeah, also. And
Yes.
Farid and Faridul. Laushi got mistake to call.
Yes, now she called Faridul as like Farid.
Laushi all Fari.
So number 3 here we have, so let's look at number 3. The question was, you have to find the local and absolute extreme values. So local extreme values means local minimum and local maximum, and absolute extreme means global. Okay, absolute means global. That means the highest point. For example, I told you in previous class. So if this is a function, so this point is the toppest point. So this is our absolute extreme, absolute extreme value. This point and also this point. So this point is the most, the topmost point, okay? And this point is the bottommost point. So this 2 point is our absolute extreme value or global extreme value. And we also find another 2 point, like here and here. So they are local extreme value or local minimum or local maximum. This is local maximum, this is local minimum, okay? This is global or extreme maximum, and this is global or extreme minimum. So guys, you already know this, right? So we have to find this local and absolute extreme values from this equation or from our function. So if we look at the graph, we can see we only have 2 points, like one is here and another one is here. And they are our local extreme values. Our global extreme values are far more away, right? Because we don't have any interval. We don't have any interval in our question. We don't have any interval given in the question. So that's why we only have local extreme values. One is here and another one is here. Okay? And we already calculated this in our previous, like in our number on map. So again, I just write down here. So this was our function and this is the derivative value. So if we calculate the derivative, so we get then we write our derivative is equal to 0. So then we calculate and we find the value of x. So x is 3 and x is minus 1. And if you also calculate the delta value, like delta is bx square minus 4ac. So if delta is greater than 0, that means we will have some extreme values, okay? And if delta is less than 0, then we don't have any extreme values, or we don't have any global extrema. Okay, guys. So here we have our del is greater than 0. That means we will have some extreme values. So our extreme values are we already found those in number 1. You see here, x equal to 3 and x equal to minus 1. I already told you that these 2 points are our critical value. So like before, you just substitute these 2 points, like 3 and minus 1, these 2 extreme point in the function, in the main function, okay, in this function. So if you substitute this 2 point in the main function, these two critical point in main function, so you will get the value of y. So for example, here if x is equal to 3, then f of x will be minus 13. And if x is equal to minus 1, f of x will be minus 19. So this point, like 3 comma minus 13, and this point minus 1 comma 19. So they are our local extreme values, okay? So our local extreme values are f of 3 is equal to minus 13, and f of minus 1 is equal to 19. And our global or absolute extreme values are also f of 3 is equal to minus 13, and f of minus 1 is equal to 19. So in this case, our local extreme values and global extreme values are same. So guys, can you understand? The steps are very simple. Just find the derivative, number 1. Just find the derivative. Just find the derivative of the function, and you write this derivative is equal to 0. And then you calculate the value of x, and just substitute this value in the main function. Okay.
More, I can understand this part. B square minus 4ac.
Okay, so b square minus 4ac.
Topo, your voice is not clear.
Really? Topu, Farin, Zakira, can you hear me clearly?
No. Omar, your voice is good, but
Yes,
Topo
I can
voice
hear
is
you.
not good.
No, it's good.
Okay. So this del.
I can
Okay.
hear everything
Yeah.
clearly.
So this del, we just calculate this del to understand that if there is any local extrema or not. Okay. So if del is greater than 0, then we have global extrema. But if del is less than 0, then we don't have any global extrema. So like
How can we find the value of b
okay, so
square
yeah,
4ac?
right.
How can we get the
Let
fact?
me tell you. So this was like x square plus bx plus c. This was the standard formula. Okay, x square plus bx plus c.
Yeah.
If you compare this equation with our derivative here, this one, okay, 3x square minus 6x minus 9. So here our a will be 3. Here a is 3 and b is minus 6.
Oh, okay. I got it.
Yeah, and here c is minus 9. Okay, minus 9.
Okay.
So this is x square plus bx plus c. And for this function, we just find the del value, or b square minus 4ac. bx square minus 4ac.
Okay, got it. You can move on.
Okay, so let me show you another example where we don't have, where we have del is equal to del is less than 0. Okay, advanced math 7.
দেশে এসেছি তখন থেকেই কিন্তু এই যে বিশ্ববিদ্যালয়ে যখনই যাই সবসময় টিচারদের বা সবাই
So guys, here we had.
My auntie.
So guys, can you see here? We had a previous homework. So it was y equal to x cube minus 6x squared plus 3x minus 2. So derivative of this function is 3x squared minus 4x plus 3. And according to our formula, we write down derivative of y is equal to 0. That means this equal to 0. And if we compare this with x squared plus bx plus c equals 0, then we get our del is minus 20. And this is less than 0, right? So it means the graph is ever increasing. So we don't have any global extrema here. Okay.
Is increasing or decreasing, bro?
Yeah,
It's minus 20.
let me show you. X cube minus 2x squared plus 3x. Minus 2x squared plus 3x minus 2.
কিবোর্ডের উপরে দিয়ে তুফান উঠাই দিছ।
X cube minus 2x squared minus 3x plus 3x, sorry. Minus 2. Where is the graph? Maybe we need y is equal to or f of x equal to. So this is our graph, okay? You can see the graph is ever increasing. So we don't have any global extrema here or extreme value here. You see we have x-intercept and y-intercept, but we don't have any extreme value here. But if you draw this graph, in our example, this was x cube minus 3x squared minus 9x plus 14. Plus 14. X cube minus 3x squared. X cube minus 3x squared minus 9x plus 14. Okay. So you can see it shows a maximum minus 1, 19 and a minimum 3, minus 13. Can you see? Here, look at my mouse.
Yes.
Minimum and maximum. So that means this function has a extreme value. These 2 points. But the previous function, as it was as the del value was less than 0, that's why this function doesn't have any extreme value. Okay. Tobu, can you understand?
Yes.
Zakira and Farin?
Yeah. Yes, I
Yes,
can
I
understand.
can understand, but um, it's a bit confusing.
Okay, don't worry. We will cover it again, okay? In our Bangladeshi lecture, Bangladeshi group study.
Yeah, it's a bit very hard to understand.
And to understand all those, you have to see my previous video, like our previous group study videos.
I saw those, but like it's still hard for me.
Okay.
You told me.
Sometimes it can be hard, but if you try again and again, then it will be easy. Okay, we can go ahead. Umar.
So at 10:02 p.m., Zakira told me my voice is not clear. Now is it clear?
Yeah, it was my internet problem.
Oh.
I first I leave, then join again, then it was okay.
Yeah, it's okay. Okay. So in number 3, we have to find the limit. So this limit is special, okay? You can see if our limit is find the limit x tends to 0, root over 1 plus x minus 1 by x. So if you just plug in the value here, like if you plug in 0 here, so it will make some number divided by 0. So we cannot, our denominator cannot be 0, okay? That's why this is not defined. This is undefined. So here we just use L'Hopital's rule to find the limit. Okay. So L'Hopital's rule is very simple. You just find the derivative of this numerator and also find the derivative of this denominator. Okay. So firstly, find the derivative of this and then find the derivative of this. So let's see the solution. So we have limit x tends to 0, root over 1 plus x minus 1 by x. So this is a 0 by 0 format, right? So we 0 by 0 format, infinity by infinity format. Then, so this formats, if we find any format like this way, 0 by 0 or infinity by infinity, so we use L'Hopital's rule. So you can see firstly this function, derivative of this function is here. This is like u plus u minus v, right? U minus v. So we can use sum rule. Firstly, sum rule. That means we have to find the derivative of this u minus, we have to find the derivative of this v. So we already know that derivative of a constant function is 0. So we don't need to think about this v anymore, okay? We can just skip this part. So we just need to find the derivative of u or this function. But this is a little critical. Because you can see inside of root, we expected it will be x, but it is 1 plus x. That means inside of root, there is another function, or we can also say it g of x. So do you guys remember composite function? F of g of x. Guys, do you remember?
Yes.
So we have two functions. One is root over and another one is 1 plus x. So here we can use, here we have to use chain rule, okay? And chain rule means outside inside derivative. That means we have to find the derivative of outer function and then inside function. So outside function is root over, right? So we already know that root over means, for example, root over x. This is x to the power 1 by 2.
1 by 2, 1 by 2.
Yeah, yeah. So root over 1 plus x, this means 1 plus x to the power 1 plus x to the power 1 by 2, right?
Yeah.
So we can just take this power down here, and we have to subtract on half minus 1. So half minus 1 is minus half. So this is half into 1 plus x to the power minus half. So this is our outer function. And what is our inside function? Inside function is 1 plus x. So derivative of 1 plus x is 1 or plus 1, okay? 1 plus x derivative. So derivative of this constant function is 0. And we know that derivative of x is equal to 1, right? ddx of x equal to 1. So that's why I write here on, okay? And then, so 1 by 2. So we can write down this way, 1 by 2. And here we have 1 plus x to the power on minus 1 by 2. 1 plus x to the power minus 1 by 2. So it can be written like this way, root over 1 by root over 1 minus x. 1 by root over 1 minus x. I have to go, please upload video. Okay, Rajiv can leave. Okay. So we just write down this way, okay? Guys, can you understand this simplified form? 1 plus x to the power on minus 1 by 2. This means 1 by root over 1 minus x.
2.
No, this means 1 by root over 1 minus x. Okay, and this 2 is for this 1 by 2.
Please repeat again, Omar.
Yeah. So we know that 2 to the power minus 2. This means 1 by 2 square, right? So we have we have 1 plus x to the power minus 1 by 2. And for minus 1 by 2, we know that half means root
Okay,
over.
I got it this part, but I don't understand the second part. Plus 1.
This one, this part.
Yes.
Okay, so we
Plus
know
1. How can I get plus 1?
yeah. So we know that root over, suppose root over 2. This is 2 to the power 1 by 2, right? So if this is 2 to the power minus, if this is 2 to the power minus 1 by 2, then we can write down this way, 1 by root over 2. Because this half will make root over 2. And we know that if we have minus in the power, we have minus in power, then we can write down 1 by 2 square, like this way.
Omar, I got it this part, but I didn't understand the second step. Plus 1.
Last one, okay.
Plus 1.
Oh, plus 1. So this is, you can see here, 1 plus x derivative. I calculated here 1 plus x derivative. So derivative of 1 is equal to 0 and derivative of x is equal to 1. That means plus 1.
Oh, okay. Got it.
Yeah. Please remove this green line. Okay. So finally we get plus 1 by 2 root over 1 minus x. So now we put this value here. And for this part, x, so derivative of x is equal to 0, x equal to 1, right? Derivative of x.
Yes.
So now we can write down on here, or we don't need to write down on, because something divided by 1 is something, right? So we just keep it this way. And now you plug in the value here. So it will be 1 minus 0, root over 1 minus 0. So root over 1 is 1. So finally we can find 1 by 2. So this is the solution for our homework. Solution of our homework.
Okay, Amo.
And now we can just talk about some
Thank
part from our lecture. So simply this was everything, and the things Laoshi discussed here.
Are you going to revise?
Yeah. So this is little complex, but it is easier. Okay, it is easy to understand if you know all these things. So I already told you all those basic things. Now we can go deeper. Like we can try to understand what Laoshi told us. Okay. So
Okay.
firstly, Laoshi just discussed about our homework, previous homework. So I already told you that this del value is less than 0. That means we do not have any extreme value. And we already learned the main value theory. So you see here, 1, 2, 3. So we have 3 conditions. Like this function have, if a function is continuous at a comma b, is differentiable in a comma b, and f of a is equal to f of b, then there exists at least one point that is c. So c is a point, okay? And this point is in a comma b, like I already told you. So this is a and this is b. So there will, if a is equal to b, then there will be a point c here. Okay, there will be a point c here. So and the derivative of and the tangent slope in this point will be 0. Like it means f derivative c is equal to 0. Okay. Derivative means tangent line. I already told so many times in previous lecture. Derivative means tangent line, and tangent line means the slope. Okay, the slope at a specific point. For example, our point is c, so the slope of this point will be 0. Okay, the slope at this point c will be, that means slope means m will be 0. Okay, and here you can see graph. We have 2 points, one is here and another one is here. So this is a, this point is a, and this point is b. So we have a point here c1. So you can see the slope, this slope is 0, right? Any horizontal line, its slope is 0. Okay, and any vertical line, its slope is undefined, or it have no slope. Any horizontal line, its slope is 0, and any vertical line, it doesn't have a slope. Okay, guys. So you see here, this function. So we have a hole here, right? So if x is equal to 1, this is x equal to 1. If x is equal to 1, then f of x is 0, right? So that means here is a hole. So if f of x is not continuous, that means this function is not continuous at 0, 1. This is a closed interval, okay? So this function is not continuous at 0, 1, because if x is equal to 1, y is equal to 0, that means y is here. So you see the value y just jumped from here to here, right? In a second. So guys, can you see from 0 to 1? If you take 0.5, so it will be x. Like if you take 0.5, it will be 0.5. So our point is here. But if you take 1, this function is 0. Okay. So 0 means the value just decreased in here. Y equal to 0 means where? Y is equal to 0 means here. So you can see we just found a hole here. That means this function is not continuous. So if this function is not continuous, so we cannot find the tangent line. We cannot find the tangent line at this point. So you can notice here, this function have to be continuous at a comma b point, right? But here in this example, this function is not continuous, right? So that's why it doesn't have tangent line. And here is another function, f of x is equal to modulus x, where x is minus 1, 1. So minus 1 is here and 1 is here. So this is our function. But the thing is, at this point, this function is very sharp, right? Like this way, very sharp. It can hurt you, right? This is like a knife. So this point is very sharp. So if a function is very sharp at a specific point, so we cannot find the tangent line. We cannot find the tangent line here. So that's why f of x is not differentiable at minus 1, 1 point. Okay, minus 1, 1, closed interval, open interval. Sorry, closed interval. Because this point here, where x is equal to 0, this function is not continuous because this is very sharp. So we cannot find derivative at a sharp point. Or if a function is like this sharp, so this function is not differentiable at this point. But if this function would look like this, then we could find the tangent line, right? Or you could find the derivative. Because this is not very sharp. This is smooth, right? So this function is differentiable, but this function is not differentiable, okay? So guys, can you understand? Hello?
Yeah, a little bit.
Yeah, a little bit.
Little bit, why little bit? Okay, it's okay, no problem. So I'm trying to make it simple as possible, okay? And we have again f of x is equal to x, where x is 0, 1. So this is x is 0 and this is x equal to 1. This math is not full, okay? Not fulfilled. So let's not talk about this. Okay, number 2, the Lagrange theory. So for the Lagrange theory, we have two conditions. So if y is equal to f of x, a function that's satisfied, that is continuous at a comma b, a closed interval, and that is differentiable in a comma b. Okay, Farin's father is calling. So if this function is continuous at a comma b closed interval, and this function is differentiable at a comma b open interval, then there exists at least one point C in a comma b at which f of b minus f of a by b minus a equal to f derivatives c. So I already told you how this looks like. Do you remember? For example, this is a point A, and this is a point B. So between this point we have another point C here. Okay. So this is we just connect these 2 points A and B, and if we want to draw a slope at this point C, or the like the f derivative C, this means a slope at C point. So this slope will be parallel. This slope will be parallel to a comma b line, okay, or this a comma b.